Hello, I'm Wesley Kephart, and this is Data 625, Assignment 6, Network Graphs, Fall 2025 for Professor Christopher Wrightson, UMGC. For this assignment, I'm comparing two internal communication networks, Network 2 and Network 3, to give each client a cybersecurity perspective on how fragile or resilient their employee communication structure is. Both organizations have 50 employees, but their communication patterns are very different, and those differences matter for both malware spread and operational continuity. On the left of my dashboard, you'll see the visualization for Network 2, and on the right, the visualization for Network 3. I've also added separate filters for each network, one for relationship, one for betweenness, so I can interactively explore each network independently. This is intentional because each network comes from a different data source, and this gives me a clean way to analyze them side by side. You could also build a global parameter for single filter controls, but frankly, I'm lazy and I'm not getting paid for this. So, starting with Network 2, this network is fairly dense and well connected. There are 96 communication links amongst the 50 employees, so the average employee interacts with almost 4 others, and no one is isolated. Several people serve as multi-hub connectors: Stealth, Shadow, Spectre, Viper, Cipher. Each have 9 or more connections. You can see their importance visually because their in-betweenness values generate brighter or darker color values in this graph. What stands out is the redundancy in the structure. If malware hits a single device, it definitely has a lot of ways to move across the network. But on the flip side, if one employee goes offline, the overall organization remains intact. Even removing the most central node leaves the remaining 49 other employees still connected. Removing the top 2 or 3 still only breaks off very small side groups. So in terms of availability and operational resilience, Network 2 is relatively strong. My recommendation for this client is to focus on monitoring and hardening the major connectors because they represent the most likely pathways for widespread infection. With strong logging and endpoint controls, this network can perform reliably and securely. Now looking at Network 3. Even though the organization has the same number of employees, the communication pattern is completely different. There are only 49 communication links, half as many as the first network, and about 70% of the employees only talk to one person. This creates a fragile hub-spoke structure centered mostly on Nebula, with secondary spokes like Starhawk and Quantum. You can see this clearly in the graph, and by adjusting the in-betweenness filter for this network, the Nebula has extremely high betweenness, far higher than any node in Network 2, which means most communication path routes through this one employee. If Nebula were compromised with malware, the attacker would have a direct visibility into many other isolated employees, and if Nebula's device went down, the network would break into smaller clusters almost immediately. Removing Nebula and Starhawk together leaves the organization fractured into tiny groups without a reliable way to communicate at all. So for Network 3, the security risk is much higher because of these single points of failure. My recommendation for this client is to add more redundant communication paths to heavily secure the central hubs with privileged access controls, monitoring, and stricter device hardening. To conclude, even though both clients have the same size workforce, their risks are not comparable. Network 2 is resilient but allows fast lateral movement if malware enters the network. Network 3 is extremely fragile and heavily dependent on 1 or 2 individuals. This So this concludes my briefing for today. Thanks for listening.